Okay, and we are live.
All right.
So I'm going to share my screen and then I'll send a link in just a moment to walk you through the project I've been working on the last, actually it's been 2 weeks. So I'm going to open up a new window. This here's the project I've been working on the last week. Let me, come on chat. There it is. Essentially, this is a continuation of a project I did a while back based on this data set. So there is the lifestyle and well-being data set made public by Yvonne Delot. He's the data set owner, and it was part of I'm going to say part of a book, but it actually was a larger project on his part. He wanted to, it's a self-improvement project. That's what the concept of the book and the website are about. And as part of it, he hosted a survey that asks participants for several pieces of information about various things important to a person's well-being and personal development. And all of the survey data is recorded. And he actually took the entire data set and made it public. So you can access this survey data. It's of course all anonymous, so you don't have people's names or addresses or anything like that. All you have is what their answers are and when they submitted it. So data sets here on Kaggle. And one of the tasks that he set forth for the data set was if you could use machine learning to try and predict a person's level of stress and what their level of personal achievement was. So a while back, I'd created a very simple submission where the user would, oh, this is the training one. Let me see. This is nope. Well, let me just skip to the better part. I created a notebook where the entire purpose was that there'd already be a pre-trained model that a person could use, and they could simply fill out the survey information for themselves, minus the last two components, and the model would then predict what their level of stress or achievement is. And you can see that right here.
All right.
And the idea was not just to predict what someone's current level of stress and achievement is. I actually wanted to take it one step further and run through every permeation of slight changes and show someone what the change is in daily stress and achievement if they'd made slight lifestyle changes. So for instance, here, if all of their answers were the same, but they had one more serving of fruits and vegetables, this is what the difference would be for their amount of daily stress and what their achievement score would be. And you can go down the line and see what the differences are.
Okay.
And I even used a color gradient here so that things would stick out a bit more. And if you'd like, you can even, using the Colab notebook link, click the link right here and run through it yourself and get your own unique answers. So since you're a bit newer to Python, I'll show you how this one works. In Colab, you just hit run all, and and down here, it's gonna prompt you for an input in just a moment. So right now it says between 1 and 5, how many fruits or vegetables do you eat every day? So for that, I'm just gonna put in 3. I think that actually probably it's closer to 2 for me. Now it's gonna prompt and say, how many new places do you visit over a period of 12 months? And I'll say probably 6. I like to go hiking and camping a lot. How many people are you very close to? And you'll just answer the questions as they come up and just fill in your answers. And I'll do just that for a moment. Oh, that was the wrong answer. Oh, I'll be right back. I'm going to grab, I left my water downstairs.
Sure.
All righty. So have you answered all the questions?
Yes.
Okay, so you've already got to see what your table looks like. And it can be kind of interesting. And to walk through essentially what the code does here. And this is different depending on which platform I have it loaded on. The first one here takes all the information from this repo and just downloads it into the local GitHub or in the local colab environment. I think it'll probably change if you move it to if you try running this from a different environment, such as your home computer. You may have to adjust some links. After that, there are a few different definitions right here, which really just define what the columns are supposed to be titled, what the pre-processing steps are needed, and what descriptions are used. And this is also that I don't have to load the data set itself. And then the model, of course, is loaded from the GitHub repo because the model's loaded there or saved there. And then here, this is where all the magic happens. This is where it takes the user input, converts it into a list, adds it to a dictionary, and then creates a series of additional entries in that dictionary that represent all the different changes that a person could have. And by the way, as a point about this, it's the score that it got for daily stress in training was very high. It can predict that very well. Achievement, it's a wee bit off on, so that take with a grain of salt. If you don't consider the actual predictions to be close to what your actual achievement is, then the rest are probably not going to be terribly close either. But all of this makes sense, right?
Yeah.
Okay. What's here? Oh. Okay. So this here is closer to what you'd see on a server-side application. You have a pre-trained model that's just loaded. It runs through it takes the user input and generates the query from that to make the predictions and return the predictions. Now, if you go back to the GitHub repo here, I took things a few steps further. So what we've seen in the class thus far is, or what they showed in the class was simply loading the model into a server and sending a query to it and getting a response back. I actually wanted something that was a bit more accessible, something that could be done outside of what's just on the command line. So I took some additional steps here. And actually, let me do a quick edit here as well. I'll do that later. So I came across, there's a particular article I was looking for. And let me see if I can find it here. Right. And I'll link this in chat in case you want to go through it. So the article right here is about actually deploying a machine learning application into a web app. So you can actually, you have a user interface. Any user, not just someone who's running off the command line, can go to a particular website and they have some sort of interface where they select their answers and then they get a response back. And this one uses PyCaret in the example. I don't use PyCaret to deploy mine or as part of the deployment process, but it's a step that can be used. And again, this one uses Flask. There's a bunch of stuff here. I'm going to skip over it just because I could otherwise just be repeating what is said probably better in this article. Well, actually, I'll explain it here. So on the back end of the project, there is app.py right here. And this one is similar to what you saw in the Colab notebook. It's got the model, right, the model loading step. And this one also, note, is coming from the GitHub repo. It's got the definitions of the column names, the stats. Actually, I didn't explain what the stats are. The stats are here because this model that's being loaded is a neural network in keras. And because it's a neural network, I have to scale all of the data that's coming into it. So for scaling, I changed everything to unit length, which is where you subtract the mean from everything and divide by the standard deviation. And that scales all the data to be between 0 and 1.
Okay.
Or is it between 1 and -1? Yeah, 1 and -1. This changes it to z-score. Sorry, I got that confused there for a moment. All right. And so here it takes the user query, so what the user sends to the server, creates the list, does the exact same steps as before, and then returns the predictions and returns that data frame as an HTML object, because this is the interface itself is in HTML and CSS. Oh, giving Lonnie a moment to connect.
Okay.
I'll probably restart on that in just a moment. How's it going, Lonnie? Oh, he's muted.
Yeah, it just takes a while to get my speaker and microphone working.
Okay.
How are you?
I'm doing fantastic. And yourself?
Good, good, good. Ramiro, you looking dapper?
Thank you. Thank you. Try my best.
So have you had an opportunity to go through the content for model deployment?
I went through representation instead. Yeah, I got them mixed up. So yeah, I'm gonna have to catch up after this.
Okay, I can just go over some basics real quick. So what's been done this far, and I'll share the link in chat so that you can follow along. At the GitHub link, there is this page right here, and it has what's essentially an entire project I've been working on for model deployment. There is the training notebook here, which I'll only very briefly go over, covers a particular data set on about stress and achievement. And this is the lifestyle well-being data set. The lifestyle well-being data set is a data set generated by survey responses from users over a period of time. And the survey was attached to a self-improvement book. So users would fill out the survey information, and that information was added to this data set, and the owner of the data set chose to make it public. We, of course, it's user level data. It doesn't have username or anything like that, so it is anonymized. The only thing identifying about it is the date when it was filled out. So we have the survey information here, and the objective is to predict two of the features: what a person's level of daily stress is, and what their level of personal achievement is. So I begun by just building a simple model inside Keras to predict on those two features. And this notebook, the one that says stress and achievement prediction plus prescription, or model training, sorry, stress and achievement model training, goes through how those models were trained. It doesn't go through the individual level, so it'll show mean squared error for the challenge was 3.3 really on average for the model, which isn't terribly great. It actually was about 1.1 for stress, because it was very good at predicting stress, and then 4.9, I want to say, for achievement. So achievement's something that was very difficult to predict. Anywho, the entire model, as part of this, outputs, or this saves the model, and then you could either do stress and achievement prediction plus prescription, or if you want to try for yourself, on Colab, in the link here, you'll notice I have the notebook right here, and in this notebook you can actually answer the questions yourself. So if you hit run all, it will load the model from the GitHub repo, load the definitions, and then you'll notice here it prompts the user for an input. So here it says something like between 1 and 5, how many fruits or vegetables do you eat in a day? And the user can put in an input. And as you put one in, a new prompt's put in. And so on and so forth. And I'm just actually going to skip through that. Come on. Oop. Okay. And I actually just cheated and put in blank, because if I put in blank, it puts the default entry instead. And then at the bottom right here, not only does it predict what your actual value is, so based on your inputs, what your level of daily stress is, and the definition's right here if you're curious, and your level of achievement. And you can see the definition here. But it also does one further. It actually runs through every permeation of what if everything was the same, but we incremented one value by one. So in this case, it shows that I would have more stress if I were to consume more fruits and vegetables every day. And I could significantly decrease my level of stress by shouting less often. And you can see for things like achievement, if I were to allocate less time for passion, my level of personal achievement would be lower. But if I committed an extra hour each day to being in flow, I could receive a higher, I could get my achievement higher. Does this make sense? Lonnie, you're muted. Okay, I'm going to assume by his silence he understood that part.
Yeah.
Okay, so back here, the goal is then to deploy this as a web application. And so if you look at the app.py file, again, I have all of the definitions right here. So what the columns are called, and this time it doesn't have the survey description data, and that's because this is on the back end. This is stuff that this is what's going to take the user input, transform it, and send an output. So this is what's going to run on the server side. So for this one, they'll get all of those answers, or it'll take all those answers, it'll generate the data frame again, and it'll return the data frame as an HTML object right there. And if we look, so the next parts are a little bit more complicated. Well, actually, the first part isn't. So there's requirements.txt, and you can look, this is all of the requirement. These are all the things that are running in the notebook or are necessary for the server. So to run through it, these 4 are running on the server. They aren't in any of the notebooks, but it's necessary to generate the server page. We've got pandas for the data manipulation. We have TensorFlow, and we have Flask. And each one has their version number. And this is very much like the Docker image that they show in the training videos. Slightly less complicated though. After that, there's a few other files here. So there is the Proc File, which this one essentially just tells, this is the file that the server is going to look for first when it's being generated, and this tells it how to run things, what to run in what order. I am not hugely knowledgeable about this part. Under model/well-being, this is where the model itself is saved and this is how keras model is saved. When you save it in output, you get two folders and the save model.pb. There's save model.pb. Inside variables, there is a couple files here, and then there's a third file called assets, which in my case generated empty. I don't, how keras saves its models, I'm not as familiar with, so I couldn't tell you what all could or should generate in that folder. Next, because this is going to be a web application, we have the home page for the web application, and all of this is in HTML. And I can't actually tell you a whole lot about what this stuff does, because HTML is not my strong point. This is a work in progress, and I had intended to have this finished to show off more today, but I'm going to instead show you the kind of broken state it's in right now. So there's some stuff here that sets what the style is of the page. You have the input fields right here, and of course the submit button, and that's the interactive portion of the page. And then there's a bunch of stuff that dictate the background. Under static, there is the style sheet from CSS, which I'm afraid I also don't know much about. I never learned CSS, so all of this is copy pasted. None of this is original to me. Hope that's not disappointing. And then I think that runs through all of it. So if one were to run this on a local machine, nope, that's for, I guess I don't have that set up. So let me go through that. Actually, I could show you it here, but let's show you it in a live environment where you can mess around with it. So the final step of this is actually deploying this model on Heroku. So I'm going to set that model to live for a moment. So this entire process, how to deploy a model through Heroku, is listed in the KD Nuggets article right here. And there are other ways to do this as well. This one was just very simple, straightforward, and free. So this is how I have the web app deployed. So currently I have it set to maintenance mode because it works. It's just not very pretty right now. So I'm going to turn maintenance mode off. So now this is live. Okay. Alrighty. So maintenance mode is off. Let me. That's not what I wanted. View logs. Okay. So here, I'm going to open the application myself, and I'll even post the link right here so you can follow along. So you can see the page is loading. It's already loaded. Now, I probably should have given it a second to boot up first. Right now, the page is loading because it's bringing the model live again. I had disabled it because, as I said, it's code complete, but the format is absolutely awful. So all of it's booting up right now. Where is it under activity that it shows? That should. One second, I'm actually going to. No, that's not what I wanted. I wonder if there's a way to restart it. That looks like it's just loading, but it shouldn't be just loading. It should be already ready to go. Junk mail.
I see something.
Okay. Good. So you'll notice right here, I have the website listed, and you have each of the user entries right here. And you can actually go in, and for fruits and vegetables, you can put, and I'm going to cheat and just do 3s across the board. Just enter, 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 do. And you'll see in a moment what's wrong with it. So it's able to generate the prediction based on the user input. These fields reset properly. If you look up here, though, that is the HTML of, that's the table that's generated. So that's the response table. And if you wanted to, you could just copy paste that table, create a new text document. Okay. Paste all that in, save, rename HTML. And I'm going to open this in Firefox. And we can see that's what's returned. So it actually does have a formatted table here that again shows what all those predictions look like, what all the
How'd
changes
you do that
are.
again?
Oh, here I just created a blank text. So actually, let me. So when I put in the predictions right here, and I assume you filled all this out, right?
Yeah.
You notice how you get this weird bunch of text at the top here?
Yes.
So this is all in HTML. If you hit copy on this, so just highlight it all, Control-C, and then you create a blank, and I'll do it again, just a blank text document. And you paste that data in. All of this is actually HTML. So you save that. You then go back to the text document and you rename it. So instead of .txt, it's now .html. And then you run that. It will create a new, it will show the table. And essentially where the issue is in the website itself, well, actually there's a few issues. Actually, before I mention it, I know you guys have we've been studying data science and machine learning, but let's talk about user interface for a second. What all could be improved here to make the user experience better?
On that page itself?
Mhm.
Well, for me, I can't scroll down, so I have to like tab in order to get to the lower fields.
Yep, same problem here.
There could be like an explanation, like what is it asking? On the code side, you're guided like 0 to 10 or whatever, whereas here it's not present.
Yep, that's actually one of the things. So you hit the nail on the head with each of those. I wanted to add a description to each, but I haven't. This is the code complete version. So all the code is there. It's formatting that I need to do. Things like adding descriptions, changing it so it displays a proper table, those sorts of things. So all of that is exactly what I want. From a functionality standpoint, it functions just fine. It takes the input, produces a valid output.
Okay. I'm sorry. So once you put it on the text document, you save it as an HTML? Is that what you said?
Oh yeah, you can save it as an HTML.
I'm not getting those options on my end.
Okay, so let me just go back here and, well, let me just delete both of these and start from scratch. So here, I'm just creating a new text document like this. I'm just going to keep it labeled new text document. Open the document, paste the data in, save it, and close. You with me so far?
Oh, yeah.
And then next, I'm just going to right click on the document itself, click rename, and then instead of leaving it as .txt, I change it to .html.
Got it.
Okay. And boom. And so you can see that's what the HTML is supposed to look like. Because of how I have this site formatted, the HTML doesn't actually print out as a table like it's supposed to. So I need to figure out how to improve that. That's going to be my next step, or a next step. So essentially, add descriptions, find a way to get all of this to fit on a single page, because yeah, I can't, in order for me to get down to the lower ones, I can actually, I just put something in and I hit enter and it'll automatically move to the next, but I can't select the bottom one for age any other way effectively. And again, HTML is something that I'm not really familiar with, so this is going to be a bit of a learning curve for me. Probably is going to be on pause for a little bit because I have some other projects I want to work on. So yeah, that is a model deployed as a web app. And do you have any questions so far?
Not me.
Okay. So I'll have the article itself posted, added to the GitHub page, and ideally I'll just have all this on the GitHub page as well as a link to the web app once I have it fixed. Excuse me. Time for a cough drop. So to walk through a couple of things that I learned in this process, or just something useful to bring up in the process. One of the challenges that a lot of people had when following in the footsteps of this is that Heroku, for its free tier, allows a project, or the max size a project can be is 500 meg. So anything that generates more than 500 meg won't be able to run on the free version. You'd need to pay to be able to. And in fact, anything running over 300 meg is going to run slow. So people who just copy paste the GitHub that this is originally based on are going to have some issues, because PyCaret now is almost 500 meg by itself at this point. It's a library that's been constantly in development for a while, and it's an outstanding resource. It offers a lot of functionality, but it is constantly in development and improving, and it's become much bigger than it used to be at the time that this was written. So you'd actually need to set it to an earlier version. And even when I was running it, you'll notice in the requirements text that I have TensorFlow, which is a pretty large library. So that actually, I wound up, this entire project takes up 447 meg. So just, it got very close to the cutoff. Or sorry, 470 something meg. So it got very close to the cutoff there. I couldn't add a lot of libraries to this. I don't know what sklearn is total size is now. Actually, I'm curious. Nope, don't know how to figure that out. Okay, that seems a bit small to me. So that is a consideration when you're working on a project like this, is trying to keep the total number of involved packages down so you don't use up too much. And in fact, well, so theoretically, I could cut out pandas and just run everything in TensorFlow, because TensorFlow itself has a matrix objects that can be used instead of the data frame objects. I just don't find them as easy to manipulate because I didn't learn in TensorFlow. And yeah, I think that pretty much covers all the content right there. So you said you'd already run through the first portion or up to productionization in Great Learning,
Yes.
right?
Yes.
Okay. So you're going to have, just so I can see where that is. Okay, so the next few things you're going to go into are Docker containerization, which is going to be similar to creating the requirements text like you see it here, only theirs uses a different format and is again so that you can mimic the development environment that a project was done for reproducibility. It talks about Kubernetes, but it doesn't get into it explains what it is and what it does. It doesn't give you a lot of hands-on practice with it, so it's nothing too complicated there. Again, that would be for if you wanted to send a query to a server and receive a response without all the formatting of the web application like what I have right here. Yeah.
Okay.
Okay. I think that pretty much goes over everything. So the next thing that I want to go through is recommendation engines, and that's going to be about 2 to 3 weeks out before that study group can happen because that's a larger one than the model deployment module. Is there anything else that you might like to learn about or anything that you think we could do additional coverage on before wrapping everything up?
Nothing comes to mind right now, but if as I'm working on stuff, I come up with something, I'll send you a quick text.
Okay. Because I could always generate an additional study session after everything else to cover a particular topic if there's interest.
Yeah, that would be good.
Okay. In that case, I think I'm going to wrap up right here.
Okay.
I'll post the video to YouTube probably sometime this morning or maybe later this evening. We'll see. So, yeah.
All right.
Thanks everyone for your time.
Thank you. You have a good day. See you, Lonnie.